Good morning, good evening, good afternoon, boys and girls. So it's time to learn about wireless networks for the new CCNA certification exam 200-301 version 1, the blueprint. Let's go with this topic. We are going to learn a little bit about wireless networks and then from basic to intermediate level. So let's go. First thing we have to learn is the agenda for today. So we have some of the following topics: types of wireless networks, how do we communicate in wireless networks, basic service set, extended basic service set, wireless repeater, wireless workgroup bridge, outdoor bridge, wireless mesh, radio frequencies, radio frequencies and channels, signal signal overlapping, and type of antennas. These are some of the topics that we will cover today. Okay, let's start with the first one. Is about the types of wireless networks. So we have the following. In this case, we have the WAN, the MAN, the LAN, and the PAN. Basically, this is what we have. Personal area network. We have IEEE 802.15, which is Bluetooth. It has a coverage of 10 meters or less. Then it comes the IEEE, and this is actually the LAN. It covers about 450 meters, is for Wi-Fi signal, 802.11. Then less than 50 kilometers, we have MAN, Metropolitan Area Networks, and this is IEEE 802.16 fixed WiMAX. Remembering that it is having a coverage of 50 kilometers or less. And finally, we have um, 150 kilometers or less for one wide area network, IEEE 802.20 mobile Wi-Fi. Now, I know it's a little bit less in miles. It's something like, per se, instead of 150 kilometers, it will be something like 80 miles here. So I know in the US they use more miles. So instead of 50 kilometers, it will be like 30 miles. So that's basically about it. So just for you to have a better understanding about the conversion. But if you want, you can actually, let's do the conversion about uh, 150 kilometers and 50 kilometers to miles. Let me just work on that for a moment. I'm going to go to our friend GTP chat for a minute, or let's use Bing. Let's use Bing. Let's use Bing so we can ask the question. Okay, how much is 150 kilometers and 50 kilometers in miles? That's what we're trying to know. I wasn't that lost. It's actually 93 miles and 31.1 miles. So that is the conversion. Basically what we need to know in this coverage that we have. So let's continue with the presentation. Gives me just a couple of seconds here to return to it. And we are talking about wireless networks today. So what else do we have here? We have another example where you can actually see the different connections: WW1, WMAN, WLAN, and WPAN. We have gone over some of these GSMS, GPRS, and CDMA. These are mainly for telephones, for cell phones, intelligence phones, smartphones. Is actually for smartphones. So let's go ahead and read the new definitions that we have over here. Let me just look for the highlighter for a moment. Let's select green color for now, and let's go with the rhythm. What do we have? We have WPAN, Wireless Personal Area Network. These networks are used in our personal space, such as wireless headphones, wireless computer means, or when using a TV remote control. Another example would be some of the new freezers that comes with intelligence, with this intelligence of Wi-Fi connections and all that. So there's like new technology for the freezer, and it comes with this smart, um, the Internet of Things. This is a smart integration of Wi-Fi and all that. What else do we have? Okay, we have WLAN, Wireless Local Area Network. This is a wireless network we commonly use in our house or in a business. WMAN, Wireless Metropolitan Area Network, used for connections between buildings. Coverage is less than 50 kilometers, and this is WiMAX. So we already saw that it is about 31 miles. And the other one that we saw before, the one for 150 kilometers, was like 93 miles, something about that, around 93 miles. Finally, we have the last one. What do you see there? W1, Wireless Wide Area Network. Cellular, cellular networks and satellite networks fall under W1. Coverage is less than 50 kilometers. Remember, it's about 31 miles. Uh, 2 gigabit is 2G, 3G, 4G, LTE, 5G, and VSAT. Those are some of the technologies that we have currently there. Let me go ahead and clear the drawings for a moment. Let's move on. Let's move on. How do we communicate with these wireless networks? Mm, To understand wireless networks, we can use sound as an analogy. Sound travels through open space and is received by our ears. If the space is very open, sounds travel freely. If there are walls, the walls absorb some of this sound. Once again, how are we communicating at this moment with wireless connections or wireless networks? What happens when two people speak at the same time? You guys remember the walkie-talkies? Um, you only receive one signal at a time. Now let's go ahead and read this definition and see what is happening here. Wireless networks operate in the same open space as the sound, so only one device should transmit at a time. Otherwise, interference occurs. This is actually called half duplex, when you are sending a message, only one message at a time for communication. And I was giving the example of the walkie-talkies. They work exactly this way. And the walkie-talkies, that's an example. When we talk about access points, what do you think it is? What will be the definition for an access point? An access point is a device that connects wireless clients to the wired network. In other words, it provides access to the network, hence its name. Some of the brands that we have been working on during the last couple of years, we can talk about Meraki. Meraki is an example of those. Um, there is Aruba Networks as well. Um, I was working with Riverbed Technologies once upon a time, and they have a technology that they actually were selling. That was also an access point technology that they sold this technology to another company. I don't remember the name, but they have Wi-Fi technologies and access points at that moment. Okay, let's continue moving forward. And what do we have here? Wireless LAN topologies. Unlike a regular Wi-Fi connection, Wi-Fi Direct does not require an access point to manage the connection, such as a router or a hotspot. In other words, without that access point, device cannot communicate. They cannot see each other. With Wi-Fi, with this option, with this new technology, Wi-Fi Direct, files can be sent directly between devices. What do we have here now? Wireless LAN topologies. Wireless LAN topologies, WLAN topologies are the structures or configurations that determine how devices in a wireless network connect and interact with each other. In this example, we have some of the devices here that are currently receiving the signal from the internet. We have a wireless router, an analog telephone, the public switch telephone line, where we have all the cables, the um, cell phone network, and the computer with wireless connection. Finally, we have a Wi-Fi phone. So those are some of the different devices that receive the signal. Mainly the ones that we can mark with an X. For example, let me just go ahead and look for a pencil here so I can mark with a small X. The Wi-Fi phone, the wireless router. This one doesn't have that much interaction. They allow the communications to travel. The the cell phone and smartphones with the new technologies nowadays. And we have Kindle devices, for example. We have laptops and desktop computers with Wi-Fi integration that they will receive this signal, this Wi-Fi signal. Let's go ahead and clear the drawings for a moment and let's continue moving on. Wireless LAN topologies. This is a wireless network that operates at very short range, less than 10 centimeters. Because of its limited range, it is used for contactless interaction. For example, to make contactless payments. When you go to the supermarket and you pay with your debit or credit card, and you have these devices for the payment, this can be an example of this Wi-Fi connection. Usually, we are talking about Bluetooth connectivity. Okay, let's continue moving forward. With this one, we have the basic service set. And this is an example where you can see at this moment, there is a total of 4 computers. This is number 1, number 2, number 3, and number 4. They are connected via an AP, an access point, and the SSID is my Wi-Fi, and we have the BSSID, which is something very similar, like a MAC address that we have seen before in the switching section. Now, going to the definition, what do we have here? Wireless LAN networks are governed by the IEEE 802.11 standard. This standard defines the concept of a basic set service set, which is a wireless network controlled by a single access point. Okay, let's go ahead and clear the drawings for a moment and let's continue moving on. We have right now in this example an admin user connected to VLAN 20 in this specific location. We have an ISR router. We have a layer 2 device. We have a Cisco access point connecting two laptops. One is in VLAN 20 and one is in VLAN 30, respectively. One is using the Wi-Fi connection called admin, and the other one is using the Wi-Fi connection called guest. Those are the SSID. We have a web server connected to this specific VLAN 30, and there is a Catalyst 2950 switch, a little bit old per se. We have more recent technology. We have the 2960 series nowadays with more advanced technology, but that's pretty much what we have. And there is a trunk port connecting the access point physically and the switch. Let's go ahead and clear this drawing, and let's go with the specific definitions that we have for this section. So first we have concept of SSID or Service Set Identifier. This is the name of a wireless network. Some access points support multiple wireless networks, and each one has a different SSID. BSSID, Basic Service Set Identifier, this is the unique MAC address that the client uses to identify which access point it is associated with. We have the Basic Service Set Area, BSA. This is the coverage area of the access point antenna within the BSS. And finally, the distribution system. In terms, this basically means a connection between the access points and the wired network. And this is an example. You can see the physical connection here between the switch, physical switch, and this is access point that is a Cisco brand access point, respectively. Let's continue moving on. And now we have another definition. But before that, let's analyze this network. We have a layer 2 switch over here. We have a BSS1, BSS2. The MI5 is the SSID for both connections. There is AP1 and AP2. We have a total of 2 access points. You can see the BSSID, which is very, very similar, like MAC addresses in layer 2 switches that we have seen before. And you have to see there is computer between the 2 Wi-Fi networks. It can receive signals from either access point, AP1 or AP2. And we have one that is directly connected to the BSS2, and the other one is connected to the BSS1. One is linked to the AP2, and the other one is linked or related to the access point 1. That's pretty much the explanation for this topology. Let's go ahead and clear the drawings for a moment, and let's take a look at this definition. This is the typical infrastructure we find in our company. Multiple access points are connected to the same LAN and transmit the same SSID. Note in that diagram that both APs broadcast the SSID my Wi-Fi. However, each AP has its own MAC address, which allows the signal from each AP or each basic service area to be distinguished. Okay, so let's continue moving forward with the next one. And we have a repeater right there. Let's take a look at this picture. This is a repeater. So it will extend the signal from one room to the other. So they have more reception, a better reception per se. Let's go ahead and clear the drawing and read the specific definition that we have over here. A wireless device, in this case, is a repeater. It receives the signal from the access point and retransmits it in order to extend its coverage. That's what a repeater does. That is one of their functions. Wireless workgroup bridge. The wireless workgroup bridge functions as a device to which wire equipment is connected, but it has a wireless network card and connects as if it were a client switch. So let's go ahead with that one definition one more time. The workgroup bridge functions as a device to which wire equipment is connected, but it has a client wireless, it has a wireless network card and connects as if it were a client switch. There are two types of WGB, workgroup bridge, and we have universal workgroup bridge and workgroup bridge, WGB. The first one, it has only one Ethernet port, so only a single device can be bridged. The second one is a Cisco proprietary. Implementing this implementation that allows multiple wired devices to transmit through WGB. In this example, you can actually see we have a mobile device, a laptop, another IP phone, a wired PC, and a laptop. So let's explain this one. We have a workgroup bridge access point interface, remembering this is a Cisco proprietary implementation that allows multiple wired devices to transmit through the WGB. And then we have WAP 361 as a root access bridge, as a root access point. Infrastructure client interface. And what do we have here? We have SG300 RP130. That's what we have. What else? What else do we have? WAP 361. That's the one we have analyzed before. But we have the root access port, WAP 361 infrastructure client interface. We have the connection between the interface infrastructure and the access point interface, which is a workgroup bridge. The other one that we have there that is not in this example is the universal workgroup bridge, and it has only one Ethernet port to a single device that can be bridged. There is also after this a switch, a layer 2, an L2 connection, and it is currently connected to a wireless router over here, and then to the internet. That's basically the topology that we currently have. Let's continue moving on. And now we have the wireless mesh. And this is an example where you can actually see a mesh controller. Let's just name controller number 1, name this one mesh controller number 2. We have a couple of switches. These are multi-layer switches. It means they can do layer 2 and layer 3 capabilities. They can do switching and they can do routing as well. And that's pretty much the topology. And the other ones are wireless routers in different channels. That's what we have. Wireless mesh networks are quite popular and effective because they offer the flexibility to expand the wireless network without the need for cabling. Unlike a repeater, an access point in a wireless mesh mode uses one frequency band to communicate between access points and another frequency band to communicate with clients. They typically use the 5.0 gigahertz band as a backhaul and the 2.4 gigahertz band to communicate with clients. So that's what we have here. Let's go ahead and clear the drawings and let's move on. Now we have a root AP, a mesh AP, and they are connected with RAP map, probably some of the protocols that connect these specific devices. We're going to read more about it in a moment. We have an access for a specific end user device. This is a wired access. This looks like a screen with access to 2.4 gigahertz. It can be a tablet, or it can be a laptop, or even a Kindle device. We have some laptops over here. This one is connected through wireless to the access point, and this one is connected physically to the layer 2 switch. There is a layer 3, layer 2 switch over here that is connected to a controller, and then we have a router. That's basically what we have. Great. Now, what do we need to do? What do we have? Think. Okay, we need to go over the definitions to understand this a little bit better. So let's go over the definitions. In this topology, there are two types of access points, APs. Root AP. The RAP is the access point connected to the wireless, to the wired network, to the wire. So we have this one connected to the wire network that is called the RAP. Also, the definition of root AP, root access point. Then we have the mesh AP. The map is the access point that is not connected to a wired network. Instead, it communicates with other APs through the backhaul. A mesh AP, let's see, is actually this one. You can see that it has wireless connection, two wireless connections via the backhaul, and there is a physical connection to a layer 2 switch. So that's what we have there. Let's go ahead and clear the drawings for a moment and let's move on. Radio frequencies. So for radio frequencies, we have upstream and downstream data. We have also video. We have over here, let me just, we have the RF signal over here. What else do we have? We have the WDM. It combines passive and decombines some of the signals, WDM. And let me just change to red color. What do we have? What else? We have data over here and we have video over there. Data for upstream and downstream, and we have video. We have optical amplified transmission with the RF signal device, physical device. And that's basically what we have in this topology. So let's go over the definition for that one. The higher the frequency, that is the greater the number of cycles per second. The higher the data transmission rate, each completed cycle is known as a hertz. Let's go ahead and clear the drawing and let's continue moving forward on this. In this example, we have the units of measurement for radio frequency and channels. Okay, so what do we have here, guys? Let me highlight those. Let's use a yellow one for now. We have gigahertz, megahertz, kilohertz. That is giga, mega, kilo. We have the power to the 9, power to the 6, power to the 3rd. So we have the power to the 9, up 10 power to the 9, then 10 power to the 6, and 10 power to the 3. So that is basically what we have. We have gigahertz, megahertz, kilohertz. Then we have the hertz, and it's actually 10 to the power of 0. 10 to the power of 9, 10 to the power of 6, 10 to the power of 3. That's what we have at the beginning. Then we have 10 to the power of 0 for hertz. Finally, we have microhertz, millihertz, nanohertz, 10 to the power minus 3, 10 to the power minus 3. There is 10 to the power minus 6 and 10 to the power of 9, minus 9. And those are basically the units of measurement for radio frequencies and channels. Let's clear this part. Now we have the following. At this moment, we have some of the frequency, and this is basically, let me just change the color for a moment. We have 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, and so on. We have gigahertz, gigahertz, 1 gigahertz, megahertz, 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 hertz, hertz, and that's pretty much everything that we have. We have 10 to the power of 29 for cosmic, 10 to the power of 21 for cosmic ray, gamma rays, X-ray, 10 to the power of 17, ultraviolet light, 10 to the power of 15, visible light, infrared light, 10 to the power of 12, and 10 to the power of 13. We have visible light, infrared light, the ultraviolet light, and what else do we have here? Microwave and radar, 5 gigahertz wireless, 2.4 gigahertz wireless and radio frequencies, television and FM radio, shortwave radio, AM radio, low frequency radio, sound. And then after sound, 10 to the power of 3, we have 10 to the power of 0 or 10 to the power of 1 with subsonic. Okay, so what we have here is basically the standards, all the different standards, and gigahertz, megahertz, and kilohertz. This is what we have here. Let's go with the definitions of these. All of these standards are governed by the International Telecommunication Union Radio Communication Sector, ITU-R. The ITU-R established a set of license-free bands that anyone can use for transmission without requiring a special authorization. These bands are known as ISM bands, which it stands for Industrial, Scientific, and Medical. The ISM bands include 902 through 928 megahertz, not used in Wi-Fi networks, 2.4 to 2.4835 gigahertz, the most popular transmission band, and then we have 5 gigahertz, widely used for high-speed wireless communication. So let's continue moving on. Let's clear these drawings and let's move forward. What else do we have? Okay, we have the different channels. We have channel 1, channel 6, and channel 11. And it is recommended to have devices in different channels so they don't overlap. In this case, we have these channels, and it is recommended to have some devices in channel 1, some other ones in channel 6, and some other ones in channel 11. Mainly, for example, if we are configuring access points, that will be an example. Wi-Fi devices automatically configure and adjust their wireless channels numbers as part of the communication protocol. Let's clear the drawings and let's continue moving on. We have the following commands. We have IEEE 802.11 family of standards as it follows. We have all the different channels. The most important ones are channel 6, channel 1, and channel 11. Those are the ones that we will be using most of the time. Now, what is the definition for this? Under normal conditions, users do not need to worry about these settings. However, users and administrators may wish to change their Wi-Fi channel numbers in certain situations. Let's clear the drawing and let's continue moving along with this presentation. So the channels for 802.11 Wi-Fi, and this is what we have. Remembering that the most important ones are channel 1, channel 6, and channel 11, which are the ones that we will be using most of the time. And we are trying to avoid the signal overlapping. For optimal rooming, access points should overlap in RF coverage, but not in channel assignment. In other words, if you have two APs, they should have overlapping signal areas, but be set to different channels, such as channel 1 and channel 6, and not both in channel 1. So I actually work with a ISP in Costa Rica. It's called Rakta, and we were adding access points. And it was important that when we were adding in a specific location of area, the access points that we have to configure like in one zone, channel 1. In the other zone, we will be configuring channel 6. And the next one, we will be configuring channel 12. So they will not be overlapping the signal and so on. That's basically what we used to do with physical installations for clients and customers. Let me go ahead and clear the drawing and move forward. Types of antennas. Okay, look at all those different types of antennas. The wireless speed, the speed of a wireless LAN will vary depending on the signal strength it can receive and transmit. Therefore, antenna selection can have a significant impact on the speed of your wireless link. We have the grid antenna, horn antenna, omni antenna. Then we have patch panel antenna, LD, LPDA antenna, and sector antenna. We can see them, but it's just there is something missing here. The word antenna is missing from here, but you basically know about that, so we don't really have to worry about it. We can see the grid one. We can see the patch panel antenna. This is called sector 1, and this is called LPDA. There are two basic types of antennas for WLAN and cellular products: omnidirectional and directional. These two types are categorized by the direction in which they transmit the radio signals. They transmit these radio signals. Let me go ahead. And this is an example of a speed test for a wireless device that we are currently running at somewhere in Costa Rica, for example. The speed of a Wi-Fi connection depends on several factors. Among them is the fact that it supports different performance levels depending on that technological standard. Then we have Wi-Fi speed. And let me just clear the drawings for a moment. Let me go ahead and just clear all of them. And let me just use the highlighter here for a brief second. We have the Wi-Fi standards are certified by the Institute of Electrical and Electronics Engineers, IEEE. Each Wi-Fi standard is classified according to its theoretical maximum network bandwidth. However, the performance of each Wi-Fi network does not match these theoretical maximums. Let's just clear them. Let's continue moving forward. And we have one of the final slides for this presentation. And those are the wireless speeds. Introducing 1999, the first one that we have here. Less interference, shorter range. It was the channel width was 20 megahertz, 54 Mbps, and the frequency band was 5 gigahertz. The standard 802.11a, 802.11b. We have now 2.4 gigahertz, It was covering a channel with 22 megahertz, and then we have 11 Mbps, and it has a longer range, more interference. 802.11g, 2.4 gigahertz, 54 Mbps, 20 or 20 megahertz. It was developed in 2003, backward compatible with 802.11b. 802.11n. It supports both 2.4 and 5 gigahertz up to 600 Mbps, 20 to 40 megahertz, and then it was developed in 2009, introduced by what we have as MIMO. Is a MIMO technology, is multiple input, multiple output. Then we have 802.11ac, 5 gigahertz, and up to 6.9 gigabit per second. It has coverage of 20, 40, 80, and 160 megahertz. It was developed in 2013. It uses MU MIMO, wider channels, and beam forming. 802.11ax. It supports 2.4 and 5 gigahertz, up to 9.6 Gbps, gigabit per second, from 20 to 160 megahertz. It was developed in 2019. That was the year of introduction for this technology, known as Wi-Fi 6 at OFDMA and a better efficiency. Finally, we have 802.11be. It supports 2.4, 5, and 6 gigahertz, up to 46 Gbps, up to 320 megahertz. Expected 2024. Wi-Fi 7 introduces multi-link operation and advanced modulation. And we are done with the presentation. I hope that you have learned something about these technologies. Let me just clear the drawings for a moment. And we are covering pretty much all the basics for wireless connections from basic to intermediate level. We don't want to go too deep into the theory because we have another class explaining a little bit about architecture, wireless architecture, and then we will be completing a lab for wireless devices, probably using the same Cisco Packet Tracer as well that we have been doing during the bootcamp. So my name is Cesar. I hope that you have liked this lesson, a little bit about this theory for wireless networks. I will see you at the top of success, boys and girls. Take care, and until next class, goodbye.